Right, so this video is about the electricity component of the assessed practicals, and there are two for this: the resistance in a wire and the resistance in a filament bulb. The filament bulb is really the one that you must know for your exam. So the first question is about circuit symbols, and that is going to be a lamp. This, remember, the arrows are showing light, and light is moving away, so light is being emitted. So we know we're going to go for a light emitting diode. That is a symbol for a diode, and here the light is going towards it, so it's going towards a resistor, so that is a light dependent resistor. Okay, this next question is about a thermistor, and thermistors have a symbol that looks like that. Okay, and what is a thermistor? It's a temperature controlled resistor. If you have a high temperature, you get low resistance, and remember, low resistance equals high current. So that is the important thing for this investigation. So I've been asked about what the symbol is. Well, it's that one. Okay, suggest one way the investigation could have been changed to give a wider range of temperatures. Well, they could have heated this liquid or cooled it down more using ice. So if we heat it up more, we might be able to heat it up to maybe 100 degrees C. So heat water to higher temperature. Okay, describe how the current through the thermistor depends on the temperature. We talked about this before. So clearly, you're looking at the graph, when you've got a higher temperature, you've got a greater current. So high temp equals larger current. Okay, use figure 2 to determine the current through the thermistor at 40 degrees C. So we'd have to draw a line up from 40 degrees C and across to that value. And that is going to give us a current in amps of around 0.02 amps. Okay, the next question says at 40 degrees C the resistance is 250 ohms. So potential difference, PD, is equal to I times R, which is I is our current and R is our resistance. So we've just worked out that our current is 0.02, and we're going to multiply that value by 250 ohms. Okay, so 250 ohms, I just need to use my calculator to do this. 250 times 0.02 is equal to a potential difference of 5 volts. Okay, the next question says, what conclusion can be made from results in figure 2 about the resistance of the thermistor as the temperature of the thermistor decreases? So remember, if temperature increases, resistance decreases. If the temperature goes down, then the resistance must increase. So the resistance increases. Right, a resistor is a component that is used in an electric circuit. So here we've got a variable resistor, and we're going to look at how a student would use the circuit to take readings necessary to determine the resistance of resistor R. Okay, so what they're going to do is they're going to have a voltage here. Now this voltage is constant because it is a battery. So if this was 6 volts, it would always be 6 volts. Here we can vary the resistance, and if we vary the resistance, we can vary the current, because V is equal to IR, and therefore I is equal to V over R. So that means that resistance is inversely proportional to current. If we increase the current, we decrease the resistance. If we increase the resistance, we decrease the current. They are inversely proportional to each other. So how could we use it? Well, when you get a question like this, you must talk about how you use the different pieces of equipment first. So the voltmeter, spell it correctly, the voltmeter is always in parallel and measures the voltage across the resistor. The ammeter is in series and measures the current. Now what we want to do is vary the resistance, so we vary the current flow. So you might want to make up some readings and say we're going to vary the current, so we might have 0.1 amps, 0.2 amps, 0.3 amps and 0.4 amps, etc. And by varying the current, we're going to see how this affects the resistance in the circuit. If we vary the current, we're going to then take voltages at these different currents, and we're going to use V equals IR, rearrange this equation, and we'll be able to work out the resistance by dividing V over I. So using our voltmeter we get our voltage, using our ammeter we get our current. We also need to say that we're going to vary this current by using our variable resistor. So that is going to vary the current flow. And that will enable us to get the resistance, and say resistance is measured in ohms. Okay, explain why the student should open the switch after each reading. Well, resistors get hot, so if you leave it open, the electrons are going to go through this circuit and they're going to heat up the resistor. If they heat up the resistor, when it gets hot, that will affect the overall resistance, because it will increase, because resistance is affected by temperature. High temperature equals a higher resistance, and the reason for that is because the electrons collide more in the wire with the metal lattice ions. Okay, so the resistance would increase if temperature increased, and this would obviously affect the results of the investigation. Okay, a student wants to investigate how the current through a filament lamp affects its resistance. So again, we're going to have a battery. We put the ammeter here. If we just get used to drawing it like this, then it's really going to help us with our circuits. Okay, so the same thing, we put our voltmeter in parallel to the bulb, our ammeter goes in series, and our variable resistor goes in series in the circuit as well. So we've used all the equipment, voltmeter in parallel, ammeter in series, we've put the battery on, and our variable resistor. Describe how the student could use her investigator to investigate how current through a filament lamp affects its resistance. So again, we would have to talk about how we use V equals IR and rearrange this, but R is equal to V over I. And then we talk about the voltmeter being in parallel to measure the voltage, the ammeter being in series to measure the current, and that will enable us to measure the resistance. But what we want to do is we want to change the current. So we've got a constant voltage here, so voltage, and then we're going to have current, and then we're going to have a table to measure the resistance. So if we know the voltage is always going to be the same, so let's imagine it's 3 volts, and then 3 volts, and then 3 volts, and then 3 volts, but we change the current. So we've got 0.1 and 0.2 and 0.3, etc. So we're increasing the current. We're going to see how that affects the resistance. Okay, so you need to talk about how we would change the current using the variable resistor, and how we would use the other instruments to measure these two values, and then how we would use that to calculate the resistance by using this equation. Okay, so I'm not going to talk through all the answers. You can look at the mark scheme for how you would work that out. Right, the next question says, describe how the resistance of the filament lamp changes as the current through it increases. So clearly, as you increase the current, you are increasing the resistance. Now the reason for this is because if we have a wire and we have our positive metal ions, remember in the wire it's made of metal, and we have our ions, and as the electrons move through the wire they collide with the metal ions in the lattice. If you try and push more current through, you're going to have more electrons and therefore more collisions, so more resistance. The more collisions there are, the more these metal ions start to vibrate up and down, and if they vibrate up and down you get even more resistance. So this is what is occurring. Current is just the flow of charge through the wire, the flow of electrons, and as they flow they must collide with the metal ions. if you have more electrons moving through the wire, you're going to get more collisions. So more electrons is more current, and therefore you're getting more collisions, which is more resistance. So how the resistance of the filament lamp changes, so as current increases, resistance increases. Use figure 1 to estimate the resistance of the filament lamp when a current of 0.1 passes through. So we just need to kind of finish this graph off. Looks something like that. And we're looking at a value here of around maybe 6.4 ohms. Okay, the current potential difference graph of 3 components is shown in figure 2. Use answers from the box to identify the components. So I'm hoping you know all of these by now. This is a filament bulb or lamp. Why is it a filament bulb? Because it obeys Ohm's law for this period here. When it is flat, that means V is equal to I times R. As soon as you get a curve, that means it is no longer obeying Ohm's law, and that is because resistance is no longer constant. You get a straight line like so when you can increase voltage and current increases at a directly proportional rate. R is showing here a curve, so that means resistance isn't constant. So for a filament bulb, resistance isn't constant because when it heats up, you get a curve. This value here is showing the negative current, so when the current goes in the opposite direction, and this value is showing a positive current value. This is a fixed resistor, and it's a fixed resistor at a constant temperature. So when the resistor is kept at a constant temperature, it obeys Ohm's law. And what does that mean? As I said before, V equals IR. So when resistance temperature is constant, increasing voltage will increase current by the same amount. You get a directly proportional graph. This is a diode, and a diode is showing that it will not produce a current flow at 0 volts. But when you get to around 2-3 volts, then the current starts to flow. So you need to put some energy into the diode to make the current flow, and when you do, you get a positive voltage. Now what does this mean? It means the current only goes one direction. You cannot get the current to go in the opposite direction. That's because a diode has very high resistance in the negative direction. So the resistance to flowing in the opposite direction is incredibly high, but at 3 volts it allows the current to flow. So diodes only allow the current to flow in one direction. Again, I've put this question on there so we keep getting the same one, so we're used to it. What is the name of this component? It is a filament bulb, and it does not obey Ohm's law when we get a curve. That is because of the temperature rise and the collisions in the filament wire caused by high resistance. Right, figure 2 shows a circuit containing a 6-volt battery. 2 resistors X and Y are connected in parallel. The current in some parts of the circuit is shown. So let's go through what this is showing as. 6 volts, because it's a parallel circuit, we always put 6 volts going in, 6 volts going in, 0 volts coming out, 0 volts coming out. That way we won't get the question incorrect. Now if 3 amps is our total current going into this circuit, if 2 amps is going that way, then we know going this way must be 1 amp. So I'm just going to put that on there. So we know the voltage and we know the current. We could actually work out the resistance if we needed to. Right, what is the potential difference across X? Well, it's 6 volts. Calculate the resistance of X. Well, now we know it's 6. If V equals IR, then R is equal to V over I. So that is equal to 6 volts divided by 2 amps, which gives us 3 ohms. Okay, the resistance of X we just said is 3 ohms. The next one, what is the current in Y? Well, if it's 2 amps there, I said it was 1 amp there. So we've worked that out already. And now we do the resistance. So again, it's the voltage divided by the current. 6 over 1 is 6 ohms. Right, when the temperature of the resistor increases, its resistance increases. So if we increase this temperature, it's no longer going to obey Ohm's law. It's actually going to look like that as a graph. because V will not equal IR unless resistance is constant. So what would happen to the potential difference across X? Well, the battery is always 6 volts, so it's always going to have 6 volts going in, and it's always going to have 0 volts coming out. So that has to stay the same. The current, well, if we increase the resistance, if we remember V equals IR, and that R is equal to V over I, and I said before that if you increase R, I is inversely proportional, so that must decrease. So the current must decrease. Now if the current decreases here, then that means the current in the total of the circuit must also decrease. So that is also decreasing. So just be aware that even in a parallel circuit, wherever you are decreasing the current, it's going to affect the total current of the circuit. Right, this next question is a filament bulb. Can you see at the very start, the current flow goes really high. Now, the reason this is happening is because before the wire heats up, you're going to get high current flow. Then when it starts to get a lot of current through it, resistance increases, and as the resistance increases, it decreases the current until it gets to a stable temperature, and then you get a consistent current value. So that's what this graph is showing. You switch it on, the current surges, the resistance increases, so the current goes back down until it reaches a constant level. So after 0.1 seconds, we've got this graph going along here like so, and that is 1.7 amps. Right, the bulb works at normal brightness for 30 seconds before it is switched off. Calculate the charge that flows through the bulb in the 30 seconds before it is switched off. Okay, so charge, you need to know two equations. I'm going to write them both down. So current, I, is equal to the amount of charge divided by time. So the definition for current is how much charge flows through a circuit in a given time. The definition for potential difference is the work done, or energy, so I'm going to put work done, per unit of charge. So these are the two equations that you must know because they're also going to help you define current and voltage. So current is equal to the amount of charge in a given time, and potential difference is equal to the work done per unit of charge. Remember, this line means per. So charge per time, work done, which is energy transferred. So it's actually the energy transferred per unit of charge. That's what that means. So the charge that flows through the bulb in 30 seconds, so we know that the current is 1.7, and we're going to rearrange this for charge. So if I equals Q divided by T, then Q must equal I times T, so that is equal to 1.7 multiplied by 30. And that gives us 51, and remember charge is measured in coulombs. Now that is spelt like this, but you just need to put a capital C. Right, calculate the energy transferred by the 12 volt bulb when it's working at normal brightness. So a 12 volt bulb, we need to use this equation because we've got a potential difference. We've also got a charge, so we're trying to work out the energy transferred, which is the work done. So energy must be equal to the potential difference multiplied by the charge. So that is equal to 12 volts, and we're going to multiply that by 51, and that gives us 612 joules. Right, between 0.02 seconds and 0.08 seconds, there is an increase in both the resistance and the temperature of the filament. Explain in terms of electrons and ions inside the filament why both the temperature and resistance increase. So again, let's talk about that in the wire. We've got these metal ions, and the electrons are going to collide with these metal ions and cause them to vibrate more rigorously inside the wire. So as current increases, the frequency of electron and metal ion collisions increases, causing lattice to vibrate more, and that will increase, so increasing resistance. Okay, right, the next one says complete the circuit diagram for the circuit above so that the student could have used to obtain the results. So he needs to measure the current in amps with a lamp and the potential difference. So we've just put again our circuit with an ammeter. We need a lamp, and we also need a voltmeter which measures the voltage in parallel. Right, which lamp will be brighter at any potential difference? Explain your answer. So if we look at the one at 10 volts, well, this one has a current of around 0.3 amps and this one is around 0.7. So really the brightness is to do with the amount of power that the bulb is emitting. So we look at A, then we're going to say that's 0.75, we're going to say that's about 0.3. So power is equal to voltage times current. Now the voltage is the same, but if we look back at bulb A has a higher current. Bulb B has a lower current. So if you think about the power in terms of this, if the voltage is the same and we times the voltage by the current, the one with the higher number is going to give us a greater power. So power of bulb A is greater as voltage is constant and current for A is greater. Okay, now lamp B has a higher resistance at any point. Explain how the figure shows this. Well, lamp B has a lower current value because the gradient is lower at all points. So because the gradient for current is much lower, the resistance must be higher because they are inversely proportional. So gradient for B is lower, so current is lower at all points, and resistance is inversely proportional to the current. Okay, so in the last question it says both lamps behave like ohmic conductors through a range of potential difference. Use the figure above to determine the range of these lamps. Now, an ohmic conductor is one that has a directly proportional relationship, which basically means V is equal to IR. So as long as it's a straight line, then it behaves as an ohmic conductor. So we're looking for the range of a straight line. So let's go back to our graph. We can see the range is something like that, something here. So I'd say for definite, we've got a range here from 0 through to maybe 1.5, where it is definitely a straight line. So we're going to say 0 through to 1.5 volts. And why is it that? Because it is a straight line. And if it's a straight line, it must be directly proportional. And if it's directly proportional, it means that V is equal to IR. Okay, so I'm going to go through all the mark schemes so you can check if you skip to this.